Okay, so now we're going to talk about Descartes' rule of signs. They don't call it a theorem, but it's like a theorem. And what it tells us is, it tells us the number of real positive real zeros. And it also tells us the number of negative real zeros. So it doesn't say anything about complex zeros or imaginary, numbers that are zeros. And it doesn't tell us anything about rational zeros. That's the rational zero theorem. Okay, this is just talking about how many real zeros are positive and how many real zeros are negative. Okay, and it says this: if you have a function, and I'm just going to make one up. What you do to find the number of real zeros is you count sign changes. Okay, so this is going to tell us the number of positive real zeros. And what I mean by sign changes, we count how many times the sign changes. Now, it doesn't matter how many terms there are. You don't have to worry about missing terms or anything like that. This is what we're saying. If you start out with positive and the next one's positive, then going from this to this, no sign change. But now we go negative, right? So there's one sign change. And now we're going from a negative to a positive, and so that's another sign change. So there are two positive real zeros, or I have to throw in an or really quick. So there could be two positive real zeros, or there could be no positive real zeros. Now that's the part that usually is confusing for students, because they're like, well, why is it 2 or 0? It has to go in pairs. So either there's two real ones or there's none. So let's say you're trying to find zeros and you find, one real zero. Then you know that one positive real zero. Then you know there has to be another positive real zero. So you wouldn't try the negative numbers. You'd try another positive number, okay? So it kind of guides you to finding zeros. It's a little bit of a guide. Okay, that's just the positive ones. Now we're going to look at the number of negative real zeros. So I'm going to use my example. And what you do is you take the function. Let me erase that. You take the function and you, another erase. Okay, you take the function and you're going to find it at f of negative x. So in my example, I would have 3 times negative x cubed plus negative x squared minus negative x plus 7. Okay, so here's the thing. If it's got an odd exponent, then it's going to change. So it's going to be negative 3x cubed. But if it's even, it's going to stay the sign that it was. Okay? So think about negative x squared. It's just going to be x squared. Oops, forgot the square. Okay. And then here you can see, okay, that's going to change to plus x. And then I'm going to have plus 7. Okay? All right, so you have to evaluate at f of negative x, and this is to find the number of negative real zeros. Okay? And then you count the sign changes. So we start out negative here, and then we're going to positive. So that's one change. And then it's positive, positive. So there weren't any more changes. So there's only one negative real zero. So that's nice to know. You know there's at least one. There's got to be one negative real zero. And there's not going to be more than one. So if you find one, then don't try any more negative ones. Try positive numbers. Okay? So that's called Descartes' rule of signs. And it's named after René Descartes, a French mathematician. Some people don't, think it's very helpful. I think it can be really helpful, but we'll give you an example of how you would use it in the next video.